here's something that should keep you up at night. Scientists have mapped the entire observable universe, calculated the gravity holding galaxies together, and discovered something terrifying. 27% of everything that exists is completely invisible. Not dark like a shadow. Not hidden like a secret. Literally undetectable by any instrument humans have ever built. We call it dark matter, and the fact that we cannot find it is one of the greatest scientific failures and mysteries of the modern age. Let me explain why this matters more than almost anything else in physics right now. Back in 1933, a Swiss astronomer named Fritz Zwicky was studying the Coma Cluster, a massive collection of over 1,000 galaxies roughly 320 million light-years from Earth. He did the math on how fast those galaxies were moving and realized something was catastrophically wrong. The galaxies were spinning so fast they should have flung apart billions of years ago. The visible matter, the stars, the gas, the dust, simply did not provide enough gravitational pull to hold everything together. Zwicky concluded there had to be massive amounts of invisible mass doing the heavy lifting. He called it Dunkelmaterie. Dark matter. For decades, most physicists ignored him. Then in the 1970s, astronomer Vera Rubin at the Carnegie Institution repeated similar observations on individual galaxies and got the same disturbing result. The outer edges of galaxies were rotating just as fast as the inner cores, which is physically impossible unless something unseen was wrapped around every single galaxy like an invisible cocoon. Rubin's work forced the scientific community to take dark matter seriously. Today we know it makes up approximately 27% of the total energy content of the universe. Regular matter, everything you can see, touch, or detect, accounts for only 5%. The remaining 68% is dark energy, which is a completely separate mystery we'll save for another day. So what is dark matter actually made of? That's where it gets embarrassing. We genuinely have no idea. The leading candidate for decades was something called a WIMP, a weakly interacting massive particle. The theory was elegant. WIMPs would have been produced in the Big Bang, they'd interact only through gravity and the weak nuclear force, and they'd be invisible to light. Experiments like the Large Underground Xenon Detector in South Dakota and the PandaX experiment in China spent years searching for WIMP signals. They found absolutely nothing. Not a single confirmed detection after billions of dollars and decades of work. Other candidates include axions, sterile neutrinos, and primordial black holes formed in the early universe. In 2023, the XENONNT experiment in Italy, one of the most sensitive dark matter detectors ever built, published results again finding no WIMPs. The silence is deafening. What we do know is that dark matter does not emit light, does not absorb light, does not interact electromagnetically at all. We only know it exists because of its gravitational effects. The Bullet Cluster collision in 2006 gave us the clearest visual evidence yet. When two galaxy clusters slammed into each other, the hot gas collided and slowed down. But gravitational lensing maps showed that most of the mass sailed straight through, completely ignoring the collision. That invisible passing mass is dark matter. The practical stakes here are enormous. Understanding dark matter could rewrite fundamental physics. It might reveal new particles, new forces, or even new dimensions we've never considered. The Vera Rubin Observatory in Chile, named after the pioneering astronomer who confirmed dark matter's reality, began full operations in 2024 and will map billions of galaxies looking for dark matter signatures. We are hunting something we cannot see with tools we barely invented for a thing we don't understand. And until we find it, roughly a quarter of our universe remains a complete and total mystery.